The last few lessons have been preparing us to use the quadratic formula and how we simplify once we plug numbers into the quadratic formula. So the quadratic formula starts if ax squared plus bx plus c equals 0. If we have a quadratic set equal to 0, then x equals the solutions to that equation are given by negative b plus or minus the square root of b squared minus 4ac all over 2a. Now this method is a universal method, meaning that any quadratic equation that you're given, you can use this method to solve. We've talked about solving by factoring, and that only works if the quadratic you're given is factorable. So, we will talk about in this lesson which problems can be factored, which problems use the quadratic formula, where do you start, and kind of the thought process behind that. So you will have to memorize this formula, but once you get used to using it a few times, it becomes pretty easy, and it doesn't seem as daunting as it looks right now. All right, so we're gonna just go through a few examples and solve some of these equations. So we have 4x cubed minus 33 equals negative x. So the first thing you have to do is get it into this form. So we need all the terms on one side and we need a 0 on the other. So I'm going to start by adding x to the left side. So I have 4x squared plus x minus 33 equal to 0. All right? Now, at the beginning, when you're just getting used to the formula, I would recommend to write out your a value, your b value, and your c value. Okay? From there, it's just a matter of plugging into the formula. All right? So we have x equals negative b. So I do recommend when you're plugging into a formula to plug in parentheses. That's just a good habit to get into. So I have minus 1 plus or minus the square root of b squared, so 1 squared, minus 4 times a, which is 4, times c, which is negative 33, all over 2 times a, which is 2 times 4. From here, it's all simplification. You've plugged into the formula, it's all simplifying. Okay, so you get x equals negative 1 plus or minus the square root of 1 squared is 1, 4 times 4 is 8, times negative 33 is 528, negative 528, and since you have a minus here, it's minus a negative 528, so that's going to be plus 528 all over 8. Okay, we got to keep simplifying. Negative 1 plus or minus the square root of 529 all over 8. All right, then I would use a calculator to see if that's a perfect square. Turns out that it is a perfect square, and since I'm running out of board space, I'm going to continue up here. Okay, so I have x equals negative 1 plus or minus 23 all over 8. And now, since we have all numbers that can be combined, I'm going to go ahead and combine those. So I'm going to split this into two different expressions, one being negative 1 plus 23 over 8, and negative 1 minus 23 over 8. All right, so negative 1 plus 23 is 22 over 8, which reduces to 11 over 4. And then negative 1 minus 23 is negative 24 over 8, which is negative 3. And there's your solutions to this equation. Now, you might be wondering, well, can I factor and get those solutions? Because those look like solutions that I got when I factored. Yes, you can. I showed this method because it's under this lesson, and I'm showing it's an option. but maybe it is a good idea to try and factor this and see if you get the same solutions. That might be a good exercise to remind yourself how to solve by factoring. All right, so let's look at this problem here. So if we think, well, I like factoring. Factoring's a lot quicker. Let's see if we can factor this. If we try on this problem to factor, we'd have negative 18 and negative 10 in our factor puzzle. We'd be asking what two numbers multiply to negative 18 and add to negative 10. Well, there are none. So this is non-factorable. So what does that tell us then? Is this unsolvable? Are there no solutions? Well, no. It just tells us that we're going to have to use the quadratic formula as the means to which we solve this equation. All right, and you'll see the solutions. They're going to look different than the solutions we got in the previous problem. So we're going to have, let me use a different color here. Writing down our A, B, and C. Okay, and then just plugging those into the quadratic formula leaves us with this. We have minus negative 10, because it's minus b, plus or minus the square root of b squared, negative 10 squared, minus 4 times 1 times negative 18. All over 2 times a, which is 1. All right, so we've plugged into the quadratic formula. Now it's a matter of just simplifying. So we have 10 plus or minus the square root of 100. Then we have minus 4 times 1 times negative 18 is negative 72, but we have minus. A negative 72 would make this a plus 72. All over 2. All right, continuing to simplify, we have 10 plus or minus the square root of 172 over 2. All right, now 172 is sort of a big number, okay? You can either go in your calculator and find the largest square root factor of 172, or you can use the factor tree that we talked about in previous lessons. So this would be 2 and 86. 86 is 2 and 43. So we have a pair of 2's. 43 is prime, so that's going to stay underneath the square root. So that is 10 plus or minus 2 square root of 43 all over 2. Okay, I'm going to finish over here because I'm out of space. So, I need to see, is there a common factor up top? Yes, there's a common factor of 2. So I'm going to factor out a 2 from the top. And that leaves me with 5 plus or minus the square root of 43 over 2. And we see that the 2's cancel, and my solution is just 5 plus or minus the square root of 43. All right, so in this problem, we have something that looks like factored form, plus 17 equal to 5x. So we cannot use the zero product property, even though it looks like factored form. We've seen stuff like this, and normally we just set them equal to 0. But we don't have a 0 on this side, so we can't use that. So we're going to have to try and get it into this form and see what we can do from there. All right, so I'm going to have to FOIL to expand this. So I'm going to get 2x squared from multiplying x times 2x. X times negative 3 is minus 3x. 3 times 2x is plus 6x, and 3 times negative 3 is minus 9. I still have plus 17, and that is still equal to 5x. All right, now I need to combine like terms. So I have 2x squared plus 3x I can drop the parentheses and combine -9 plus 17. Okay, so that is positive 8. I still have that's equal to 5x. Now I need a 0 on one side. That's the beginning part of this conditional statement. So I need to subtract 5x from both sides. So I've had 2x squared minus 2x plus 8 equal to 0. Okay, now here's a little key with equations. Notice our numbers, there's 2x squared minus 2x plus 8. There's a GCF of 2 on the expression on the left. So before you start solving and trying to figure out any method to solve this, divide out a 2 on both sides. Okay, that makes our number smaller, which makes the process of solving slightly easier. Okay, so we end up with this equation here. Now, again, I'll try and factor. I'm looking for things that multiply to 4, two numbers that multiply to 4, and add to -1. Well, that's impossible. It's not factorable. So then what do I do next? I revert to the quadratic formula. All right, so A is 1, B is -1, C is 4. All right, so I'm going to have x is equal to minus b, so minus -1 plus or minus -1 squared minus 4 times 1 times c, which is 4, all over 2 times a. Again, I'm out of space, so I'm going to come up here. All right, I need to simplify this. So I'm going to have x equals 1 plus or minus -1 squared is 1 minus 16 all over 2. Simplifying some more, I'd have 1 plus or minus the square root of -15 over 2. To simplify that, I got to take out an I because of the negative underneath the square root. Square root of 15 can't be simplified anymore. There's no common factors up top, so this is as simplified as it gets. These are my solutions. So we call these solutions, these are complex solutions, solutions that involve I. So the directions have changed a bit, and we're finding the x-intercepts of the following. So I'm going to do 3 different equations, and we're going to see the x-intercepts of those. So we have f of x equals x squared minus 4x minus 5. All right, so we found x-intercepts before this year with absolute values. It's the same process, okay? We set y equal to 0 or f of x equal to 0 if it's in function notation. And then we have this quadratic equation. All right? Now we have 2 methods. We've talked about how to solve by factoring and how to use the quadratic formula. Those are 2 separate methods that produce solutions to equations of this form. I'm going to recommend starting with trying to factor, and then if factoring doesn't work, then use the quadratic formula. But you are welcome to always use the quadratic formula. All right, so I'm going to try to factor. So A is 1 times C is -5. So 1 times -5 is -5. So I'm looking for numbers that multiply to -5 and add to -4. All right, well that's -5 and +1. Okay, so I use those 2 numbers to split the middle term. Okay, these 2, if we combine them, make -4x. Okay, after we do that, we group. Take a GCF out of each group. Now this is a common mistake I've seen people make already this year. Notice we already have in parentheses what's here in parentheses, and we know that those should match. So I should get x minus 5 in this parenthesis. Well, what do I have to factor out if that's already there? Well, we have to factor out a 1. The GCF is only 1. So now we factor by GCF again because there's a common factor of x minus 5 in the two terms up here. So we have x minus 5 times x plus 1. And then using the zero product property, we'd have x minus 5 equals 0, x plus 1 equals 0, so x equals 5, or x is negative 1. So our x-intercepts for this function are 5, 0, and negative 1, 0. We're still finding the x-intercepts, so I'm going to start by trying to find the x-intercept using factoring. All right, so in factoring, we multiply a times c, which is negative 20. The value of b is 10, so we're looking for two numbers that multiply to negative 20 and add to 10. Okay, well there's no two numbers that work, so this is not factorable. All right, so when I have 0 equal to 4x squared plus 10x minus 5, I know factoring isn't an option. All right, so I'm going to use quadratic formula. So I have a equal to 4, b equal to 10, c equal to negative 5. So I'm using quadratic formula, so I'm going to have minus 10 plus or minus the square root of 10 squared minus 4 times a, which is 4, times c, which is negative 5. All over 2 times a, which is 4. All right, so that'll leave us with negative 10 plus or minus the square root of 100 plus, well, let's see why it's a plus. Hold on a second. We have minus 4 times 4 is 16. 16 times negative 5 is negative 80. So you had minus a negative 80, which will make it a plus. All over 8. All right, so we got to simplify. So we have negative 10 plus or minus the square root of 180 over 8. So I have to simplify the square root of 180. Again, I'm going to use the factor tree. Notice I have 2 squared and 3 squared as a factor, and 5 is what's left as a single. So the square root of 180 is 6 times the square root of 5 over 8. Out of room, so I'll finish on the right side there. All right, there's a common factor of 2 in the top. And inside the parentheses, I'd have negative 5 plus or minus 3 square root of 5. And that's all over 8. 8 has a common factor of 2. So those common factors will cancel out, and I'm left with negative 5 plus or minus 3 square root of 5 all over 4. That's my solutions. Now, my x-intercepts, what does that mean for my x-intercepts? Well, it means that there's 2 x-intercepts, okay? There's 2 because of the plus or minus. So I'd have negative 5 plus 3 square root 5 over 4, comma 0. That would be 1 point. Okay, the second point would be negative 5 minus 3 square root 5 over 4, comma 0. So these x-intercepts are different from the x-intercepts that we saw in the first problem. We call the solutions, or the roots in the first problem, rational solutions. Those were rational numbers. We call these numbers irrational solutions. And you're going to notice when the quadratic formula is the only option to solving the equation, okay, your roots are either going to be irrational or they're going to be complex. Okay, when you can factor, we call those solutions rational. Okay, so that is an important topic that will come up in the next lesson, so kind of keep that in mind. These can be graphed on the xy plane. Okay, they're just not pretty looking numbers. Okay, so last example, we have 3x squared minus 5x plus 5. So again, just like the previous problem, I'm going to try and factor it first. Okay, so I multiply a times c, that's 15. B is negative 5, so I'm looking for two numbers that multiply to 15 and add to negative 5. Okay, it doesn't work. It's not factorable. So when I go to find the x-intercepts, I know that my only option is using the quadratic formula. So a is 3, b is negative 5, c is 5. So plugging that into the formula, I have x equals minus negative 5 plus or minus the square root of negative 5 squared minus, for now, 4 times a times c, which is 5, all over 2 times a. Okay, now I gotta combine everything that's underneath the square root. So I'm gonna have positive 5, because minus a negative makes a positive. 5 plus or minus the square root of 25 minus 4 times 3 is 12 times 5 is 60. Okay, and I get x is equal to 5 plus or minus the square root of negative 35 over 6, which that simplifies to be 5 plus or minus I square root 35 over 6. Now, the question asks for the x-intercepts. This is a complex number because of that I. So, can we put that on the xy plane? And the answer is no. This will not show up on the xy plane. So what does that mean as far as our x-intercepts? Well, this tells us that there are no x-intercepts. Okay? And this is because we can say, since the solutions are complex. Okay, so we can always solve a quadratic equation and get solutions. Sometimes the solutions are rational, sometimes irrational, sometimes they are complex, as in this case. But when we're looking at x-intercepts, x-intercepts don't go on the complex numbers do not go anywhere on the xy plane. Therefore, there's no x-intercepts with this type of solution. All right, I hope this video helps, and let me know if you have any questions. Talk to you soon.